Hello students. Today we'll discuss more about the same topic we saw in our previous lecture, that is about hypothesis testing, and we also discuss about covariance factor which are used in this particular testing. Now, when we talk about hypothesis testing in our previous lecture, we saw what exactly hypothesis testing is and why we use hypothesis testing, in which scenario we implement hypothesis testing. We also saw the types of hypothesis testing, that is basically there are two types, null and alternative, which I am sure you must be pretty clear with the concepts. Coming on to again a very important topic in this exam, in this case, which is a regression. Now, again, regression is a well known statistical technique to model a predictive relationship between several independent variables and one dependent variables. Now, what is dependent variable and what are independent variable? The term itself indicates that the dependent variables will be the variables which is again dependent on the other factor or other variables, and independent variables will be those variables which are not dependent on any other factor or any other variables. We can consider the example of a relationship between food intake and a body weight. Now, if we consider this example of a food intake and body weight, then it is very much pretty clear. I hope so it must be clear to you also, that food intake is an independent variable and body weight is a dependent variable. Why? Because body weight depends upon the food intake we take. The more food intake we take, the more will be the body weight, and the less food intake will be, then the body weight will be automatically decrease. So ultimately, if we consider this example, then body weight will be the dependent variable and food intake will be the independent variable. Same example we can take of hours of study and mark score. Now, in this particular example also, uh, hours of study is entirely a independent variable and mark score is a dependent variable. On which factor mark score will be dependent is, obviously mark score will be dependent upon the hours of study. The more you study, the more hard work you do, the more marks you will score. So in this particular example also, mark score is a dependent variable and hours of study is the independent variable. Now, the most important thing which should be noted is there can be more than one independent variables. But obvious, if we can consider the example of your percentage also, your percentage depend upon not it does not depend on any single subject. It depend upon all your five subjects which you need to appear. So if in case if you are not appearing and in any particular subject or in any one or two subjects, your percentage will automatically decrease. So your percentage is dependent on all the five criterias or five subjects. So your percentage will be a dependent variable and all the five subjects will be an independent variable, because they are not connected with each other, they are not dependent to each other. So in this case, the diagram which you can see, the red line indicates a regression, which is known as a line of regression. So basically what regression is, it is a technique which indicates a relationship between one or more independent variable and one dependent variable. So in this diagram, it is very pretty clear to understand that the blue dots which you can see, blue dots are nothing but the dependent and the independent variables, and line of regression which is marked by the red line, it is moving in upward direction. And what does it indicates? It indicates that dependent and independent both variables are increasing. As independent variable is increasing, so dependent variables is also increasing. So it is actually indicating the ratio of increment of both independent and dependent variable. Coming on to the next topic, which is covariance. Now, what exactly covariance is? It is a statistical measure of the degree to which two variables move together. Two variables move together means it actually indicates the degree to which two variables move together. Now, we can consider the example of age and income. So as your age increases, your income also increases. So in this case, both the factors are in increasing order, that is, as age increasing, income also increases. Okay, so x and y, both the terms are increasing. So what covariance indicate? It indicates the ratio of degree of measure between the variables, that is either both variables must be decreasing or increasing, or one must be increasing and other must be decreasing. So either of the in either of the cases, covariance in actually is a measure to which the two variables move together. Okay, so there are two different formulas used for calculating covariance for population and for sample. Now, for population, we'll use the first formula, and for sample, we use the second one. The first formula indicates, you can see there is n, what n indicates, it is the total number of data set in the population. And in sample, we are taking it as n minus 1. N minus 1 is total number of data sets in the sample. Now, x bar and y bar, you can see, which are nothing but the mean. We have already saw what exactly mean is, and we know how we can calculate the means. So after calculating the mean, we need to put it in the formula, and we must be having a data set of either of population or sample on whatever we are working. That data set we need to take, and according to that we need to calculate the value of n, and we'll be calculating the covariance. Now this thing would be more clear to you when we will solve a particular numerical for finding the covariance in our further lectures. Next is correlation coefficient. What exactly correlation coefficient indicates? Correlation coefficient indicates that it is a measure of strength of a linear relationship between two variables. Now, correlation coefficient actually is used to define a linear relationship between two variables. Either with two variables in this case are independent and dependent variables. So if we consider the first case, that is a positive correlation, it is shown in the figure, positive correlation. Positive correlation means your both factors must be in increasing order. As we have taken the example of body weight and food intake, as you increase your food intake, your body weight automatically increases. As you decrease your food intake, your body weight decreases. So in this case, what is happening, your variables, both the variable, that is your x and y variable, body weight and food intake, both are increasing. So it is a kind of the positive correlation between these two variables. So if we consider this example of body weight and food intake, it indicates a positive correlation between the two. Now coming on to the negative correlation. Same example also you can take, or even you can take the example that if your income decreases, you what you do, you if your income decreases, you cut off your expenses and all. So when your income decreases, your expenses are also reduced. So it is going in decreasing order, both the factors are going in decreasing order. So that is known as negative correlation, in which both the factors are decreasing. Coming on to the no correlation, it is the scenario in which there is no relation between the two variables. As if, like for example, we can take for example your sales of car in India is increasing, and your income is decreasing. Now does it has any relationship? No, because your income is decreasing, that is entirely depends upon your luck factor, your hard work, and whatever. If you're working, if you're running any business, whatever scenario, that is entirely a different scenario why your income is decreasing. It has no relation with the sales of car in India, right? So it is a kind of relationship, or you can say that there is no correlationship between the two variables, because both these variables are entirely different. If sales of car in India is increasing, that will have no impact on your job, on your income, right? So any such example in which two variables does not have any difference, or you can say any two variables which does not has any relation, then it is known as no correlation between the coefficient. Okay, so if we are talking about correlation coefficient, then we have three categories in it: positive, negative, and no correlation. Coming on to the next concept, that is intercept. Again, if we are talking about intercept, that then what it indicates, if independent variable does not move, how much dependent variable move. Now you can simplify it by saying that impact of independent variable on dependent variable is intercept. So what exactly intercept is? It is nothing but the impact of independent variable on the dependent variable. That is, in short, in simple words, you can say that how much impact a independent variable has on dependent variable. Now in this case, we are considering again a small example. For example, if we have opened a new shop, okay, now if we have opened a new shop, what we need to do for sales? We need to do some advertisement either offline, or in we need to give advertisement in newspapers or in radio, or we need to use social media sites for advertisement, right? Or we can use WhatsApp also for advertisement. Some form of advertisement we need to do, because how people will come to know about a new shop, about the new opening in a new area, right? So actually, if we say, if we are opening a new shop, what on what factor sales will depend? Sales will depend upon the advertisement, right? Advertisement in this case will be a independent variable, and sales will be a dependent variable. And on what factor sales will depend? Sales will depend upon the advertisement you do. The more advertisement you do, the more popularity it will be, the more sales it will be. So if we talk about this example, advertisement will be an independent variable and sales will be a dependent variable. So actually, what intercepts indicates, for example, if we have not done any advertisement, we are assuming the case that we have not done any advertisement, and then also from the first day only our sales is improving. So it is just like a miracle that independent variable has not done any kind of job. That is, we have not done any advertisement, and then also the sales factor is, that is, the dependent variable is increasing. So it is actually indicating the impact of independent variable on dependent variable. Okay, so intercept is nothing but it indicates the impact of independent variable on dependent variable, or you can say the impact that independent variable is not doing his job, then also dependent variable is doing his job. Okay, though dependent variable is dependent on the independent variable, but then also it is doing his job. So basically, I hope it is clear to you what exactly intercept indicates. In our further lectures, we'll discuss more topics about the same, that is about probability and regression techniques. Thank you.